So we are going to start our next type of instructions today, um, which are called the store instructions. So again, let's recall the list of registers that we have. This is the same list that we have seen in the last lecture. So just recall that we have several registers, and most of the registers are 2 bytes long, except the accumulator A, accumulator B, and condition code register, which are 1 byte each. And accumulator D does not exist physically, so that's a logical register, which actually is a combination of accumulator A followed by accumulator B. All right, so what exactly these instructions do? Okay, so this is the reverse instructions of loading. Okay, remember what loading used to do? The loading copies your data from memory to register. Okay, now what happens when you are done with the operation? Let's say you load it into register and then you did some operation, maybe you did addition, subtraction, or something else, and then you have the result in the memory, in the register, and then you actually put it back to memory again, right? Because you take the data from memory, you do some work, and then you again put it back to the memory. So the store instructions are the one which does it. Okay, so it's meaning that store instructions put the data back to the memory location. Okay, now here we have, as you know, that we have 1 byte long register, we have 2 bytes long register. So that means if you are putting something back from 1 byte register, as you can guess that you will need 1 byte of memory location, right? But if you are putting something back from 2 byte long register, so you will definitely need 2 byte long register, right? And in the instruction set, especially in the column 3, there is a little math description which tells how, meaning what are the memory locations you need to you need to store, or you need to do the operation. Here you will see that in case of 1 byte is always written M in the column 3. In case of 2 bytes, it's actually written M colon M plus 1. Now this means that any memory location, and including the following one, because M is any memory location and M plus 1 is just the next immediate location. Okay, so that actually means like 2 consecutive bytes. So again, as a reminder, the store instructions are just the reverse instructions of load instructions. Okay, so the load copies the data from memory to register. Now the store instructions again put the data back to the memory locations from registers. Okay, so we have several store instructions. So again, as you can guess, each store instructions for specific type of register, right? For an example, the very first one, STAA, stores 1 byte content. Again, most of the time by content we mean data. 1 byte content of accumulator A into memory location. And since accumulator A is 1 byte, you will be putting back 1 byte. Store, this is for the accumulator B. Third one is for accumulator D again. Accumulator D is 2 byte data, right? So you'll put it back to the memory location. Here we have the first one for index register X, next one for index register Y, and the last one, STS, is for stack pointer. Okay. Now let's look at a couple of examples. Let's say we are given this instruction. Okay. Now the first question you see an operand here, right? What is this operand? Is this an address or a data? It's an address, right? How can I tell? Because the addressing mode is extended, right? As long as the addressing mode is extended or addressing mode is direct, we can tell the operand is an address. Okay? So that means this is an address, and we change the address to hex. So that's why I put a $sign. We always do it, right? We change that to $sign. Now what operation we are doing? We are actually putting 1 byte of data from accumulator A to this memory location. So this is actually the destination, okay? Remember, you actually copy from A and you put it back to memory location, right? Now you need to know where. I'm saying memory is all the bunch of addresses, right? So you need to know the address where you put it back. So this is actually the address. So again, since here I wrote it as an address, I wrote it 03D2 because I always want to write it as 2 byte, even if the 0 is not given in the instruction. So, but we know that for sure all the time. So let's try another one here. Again, this is an address, 248. And how can I tell? Because this is direct, right? You can tell from here. So we change it to extended. I'm saying to hex. Now, the tricky part is this is for index register Y, right? STY.
Yeah.
Now the index register Y is a 2 byte long register.
Yeah.
Now since you have 2 byte long register, that means when you will put it back, your data, meaning your content, will go to 2 different memory locations, 2 consecutive locations, right? Now this is how it will work. Your data has 2 bytes, right? Now your data has a left byte and the right byte. I'm saying any data will have a left byte and right bytes whenever you have 2 bytes, right? The leftmost byte is the higher byte because those have higher weights. So that actually goes to the memory location 00F8, which is given in the instruction, right? And the lower byte, which is the next byte, will actually go to the following memory location, which is 00F9. Now this is something you need to look at here. The F9 is not given in the instruction because instruction you will be given the first memory location where you will start storing the data. Okay? So and the following location you will automatically count. That's what I'm saying. So you actually start from F8. Since your data is 2 byte, so you actually keep the higher byte in F8, automatically lower byte goes to F9. Okay? Any question here? We'll see some more examples. So basically, if you understand these, you should be able to answer all of the questions that we have in our next quiz. Okay? So most of these instructions are meaning the easier ones, the storing instructions. But one thing, let me remind, if you look at your instruction set, you will not see that the store instructions support direct instructions, right? Check your instruction set. Remember, we have seen this before, that some instructions do not support some specific modes, right? I'm sorry, I was talking about immediate. So any store instructions do not support immediate instructions. Why might be the reason? The reason is this, because that doesn't make any sense, because the store instructions, by store instructions you want to put the data back from the register to an address, right? You need to know the address. So there is no point of having a data in case of operand. That's what I'm saying. Because you need to know an address where you will put it back. And what you are putting back, for an example, in case of Y, you are putting back what you have in Y currently, right? If it is accumulator A, whatever you have now in A, you are putting that back. Okay, so you already know the data. What do you need to put it back? Okay, so the all you need to know from the instruction is what is the destination address, and that is the reason any of the store instructions do not support immediate, because there is no point of having the immediate instructions here. Okay, because the operand cannot be an data. Operand must be an address. So any question? If not, let's try our next quiz, which is quiz 4. In quiz 4, in each question you will be given a store instruction, okay, and then you have to tell us what data will be loaded into that address given in the instruction, okay. And again, in addition to the instructions, you will be also given what you have in accumulators or registers, okay. But the most of the question will say, okay, you have these in accumulator A, what will be loaded into this memory location? So you automatically know that that data will be loaded into that location. Let me give, let me stop this presentation so that we can try our next quiz, which is quiz 4.